Hello everyone, in this video we're going to go through the bundle branch blocks. To begin with, we're just going to recap what the normal conduction through my heart is. So these will be my normal views. And for bundle branch blocks, they are most easily identified if we use leads V1 and V6. So if we get a septal view through V1, of course, and a lateral view through V6. The bundle branch blocks, they can be seen in other leads as well, but V1 and V6 are usually the ones in which is most obvious. So what is the normal conduction? Usually, what's the normal path of my action potential through my bundle branches? So obviously my action potential will then begin at first from my AV node, my SA node, travel down to my AV node, have a small delay in here, go down my bundle of His, and then usually what happens, my action potential will travel first down my left bundle branch, and while this happens, the action potential then gets transferred. If you can see it right here, we go to my right bundle. That's because my left bundle branch, there is two different strands of fibers, of pacemaker cell fibers going through there. So what happens? The action potential gets transferred to my right bundle branches, and once that has happened, then both my ventricles, what they do, they depolarize at the same time. So then once the action potential is passed from my left bundle branch to my right one, then we go, my left and my right are depolarized at the same time during a normal conduction. Now, what does this mean? How does this translate into my ECG? Let's have a wee look. So if we look at V1, for example, just here, let's remember that every time an action potential travels towards your lead, it's a positive deflection. And whenever your action potential travels away from this lead, it shows on your ECG as a negative deflection. So this very first transfer from my left bundle branch to my right one over here, it will show on my V1 as an initial. So we've got my P wave here, and here we go, my PR interval. And then it will show as an initial positive deflection, just like that. After that, we said that both ventricles will depolarize at the same time. But as far as electrical conduction goes, my left ventricle is significantly bigger, yeah? So what's going to happen is that my ECG is going to pick up the depolarization of my left ventricle, and the depolarization of my right one will be hidden behind it in my ECG. That's why, despite both ventricles in a normal situation depolarize at the same time, what happens here, I will pick up the depolarization of the left ventricle, which currently is traveling away from lead V1, yes, towards V6. So what's going to happen here? After this slight positive deflection, it's going to be a big negative deflection this way. Now, what's going to happen in V6 then? In V6, let's have a look. My action potential will first go from my left branch to my right. So that is going to be a small, so I've got my P wave, here we go. It's going to be a small negative deflection because the initial transfer of my action potential is going to travel away from V6. So from this side towards my right bundle branch. Yeah, so that's going to be a slight negative deflection to begin with. And then what happens? Both ventricles depolarize at the same time, but my ECG will pick up primarily the depolarization of my left ventricle, therefore big depolarization towards V6. Yes, you can see the arrows traveling towards V6. That's why in V6, that's why on my lateral view of my heart, right? So you can probably see that in lead 1 as well. In this depolarization, you will have quite a big positive deflection there. Now, admittedly, in V1, it came a little broad. So I tell you what, let's rectify this now. Here we go. So it's not as broad as that. It's nice and narrow. Here we go. That's my. This would be my normal V1 and normal V6. Okay. So moving on. What would happen then during my right bundle block? During my right bundle branch block, instead, what I will have is a little, obviously, as the word said itself, a little blockage right here. Let's say in my right bundle branch. Now, the fact that there's a blockage there, if we think about it, is not going to necessarily impact much of my initial conduction, does it? Because here I've got action potential traveling from my SA node to AV node. Obviously, down is going to go down to Buckman fibers and all the rest. AV node down here, bundle of His, and then what did we say? That is going to go first down my left, and then transfer this towards my right bundle. But the only issue that we have here now, so it's still going to go down this first left bundle branch, but it's not going to be able to transfer my signal across to my right bundle branch. So what's it going to look like? Let's have a look at what is it going to look like on V1, for example. So in V1, got it right here, there is not going to be a huge difference at first, is it? Because it's going to go across towards B1, across my right bundle branch. So there's going to have, so it's B, here we go. So it's going to be an initial positive deflection right there. Here we go. And then it's going to get this depolarization of my left ventricle. So my initial action potential is going to go and depolarize my left ventricle first. So it's going to travel away from V1, and that's going to give me a negative deflection right there. But what's going to happen here? In this case, my ventricles are not depolarizing at the same time. So it's going to depolarize my left ventricle first because there is no blockage in my left bundle branch there. And then my action potential is going to travel through my cardiomyocytes, because as we know, because of the gap junctions in between the cells, my action potential is able to travel through all my cells here. But because there's a blockage here, it's not going to be able to use its normal conduction system. So what's it going to do? It's going to depolarize my left ventricle first, which is what's happening here. And then my action potential is just going to travel back the way again, this way, and depolarize my right ventricle then. So at this point, we had this negative deflection for the depolarization of my left ventricle. And then what's going to happen? There's going to be a positive, because you see now the action potential is traveling towards V1. It's going to be another positive deflection here to go for the depolarization of my right ventricle, giving the very characteristic RSR morphology of my V1 lead in a right bundle branch block. what's going to happen in V6? Well, let's just have a look at the same, right? So we said the initial process, it's not different, is it? So I'm going to have my left bundle branch that's going to try to transfer the signal across to my right bundle. Okay, so it's going to travel away. So it's going to be a negative deflection to begin with. And then we're going to have a main depolarization of my left ventricle, therefore a positive deflection there. And then the action potential is going to travel back the way through the septum again, and to depolarize my right ventricle, which is an action potential traveling away from V6, which is going to be a big slurred negative deflection here, and then back to isoelectric line. So what we've got here, we've got obviously my first negative deflection, therefore is a Q wave, my R on top here, and this is a big slurred S wave that I've got there, and that's what is typically seen in V6 during my right bundle branch. So what are the ways we've got to remember? So aside from my RSR morphology in V1, this is what, as a reminder, we also have Morrow. Here we go. Why Morrow to remember this? Well, let's have a look at it. So if we got my deflection going up, and down again, like my RSR, it just reminds you of the letter M. Okay, and in V6, it's going to be a down deflection, up, down, and up, like a letter W, right? So Morrow, and the two R's in the middle are to remind you that that's a right bundle branch at that point. Next step, we're going to move on and talk about our left bundle branch block. Now, a left bundle branch block diagnostically is more important because obviously, as if my left ventricle is stopped from beating properly, that is an issue, obviously, because it's my left ventricle that is going to pump most of my blood out of the aorta and then to go and perfuse all my vital organs. So this is a very important one to recognize. So let's have a look where the difference is here. We have still my action potential. It starts my SA node. It's going to travel through Bachmann bundles. So my atria depolarize. Action potential travels down. Here we go. So I'm going to my AV node. Here we go. Here is going to have a small delay in there. Then it's going to travel down the bundle with his. So this is going to try. And here I encounter a blockage in my left bundle branch. So how am I going to recognize this in my ECG? Let's think about it. My action potential is not going to be able, really, at this point, to travel from my left branch to my right, because it's not going down my left branch at all. So it's going to start here. It's going to go down my right bundle branch instead, and it's going to attempt to transfer the signal through my pacemaker cell. It's going to try to transfer my action potential to my left bundle branches instead. Yeah. So what I'm going to see on my ECG, instead of an initial in V1, instead of seeing an initial positive deflection, I'm going to see this negative deflection because the signal here, you can see it, is traveling away from V1. So I'm going to have an initial, so that's my P, PR, here we go. I'm going to have an initial negative deflection right there. What's going to happen next? So at this point, though, it's going to be my right ventricle that is going to depolarize first, because here is not conducting. Therefore, it's going to be my right ventricle that is going to depolarize first. And if the right ventricle is the one that is depolarizing first, what am I going to see? What I'm going to see, another positive deflection towards my V1. Here we go. So another positive deflection here. Got not a huge one though, because it's my right ventricle and it's a little bit smaller. And then this action potential is going to travel back the way, just like that, through the septum again, in order to go and depolarize my left ventricle. Yeah, and this will give me, because the action potential is now traveling away from V1, yeah, it's gonna give me quite a big negative deflection right there in V1. So let's have a look at V6 instead. What's going to happen in V6? So my initial deflection is going to be from my right bundle to my left, so towards V6. So instead, I'm going to have a small positive deflection there at first. And after that is going to be my right ventricle that is going to depolarize first away from V6. So I'm just going to have a negative deflection there. And then my signal is going to travel, my action potential is going to go back the way again through the septum in order to depolarize my left ventricle right here. So it's going to travel again towards V6, giving me a positive deflection there, roughly. And this is the morphology in a left bundle branch block. If we want to use the mnemonic as we did before, the word here is William. So for the branch blocks is William Morrow. So Y William. See, it gets negative, positive, negative, positive. Reminds you of a W. LL, left, and M. You got positive, negative, positive, negative this way. And it will remind you of the letter M. L this way. Also, other way to remember is that usually V1 will still have a big negative deflection, so you can use a steering wheel method if you want, and so on. For bundle branch blocks, what to remember always is that when you look at an ECG, an initial thought is this a bundle branch block whenever you see this wide QRS complex? So if there is a delay in the polarization of the ventricles, it's not necessarily a block, but that should be high level of suspicion. There's a wide QRS. Let's have a look at V1 and V6 and see what we find. So in both cases, as you can see here, we have quite wide QRS complexes in both cases. And when you have a look at V1 and V6, have a look at their morphology, and hopefully this will help you determine